Hello everyone, welcome to this video. In this video, let's take another question which states we need to find the inverse of this element, which is a 2 cross 2 matrices having entries from Z11, right? In this group, general linear group of all 2 cross 2 matrices with entries taken from Z11, right? If you remember what is Z11, this is a multiplication modulo group, right? Having entries from 1 to 10, right? So here, let's take this element. We name this as A. So let A is equal to 2, 6, 3 and 5. So we wanted to find A inverse, right? So how can we do that? You know the formula to calculate A inverse. We already know that what is A inverse? It is given by the determinant of A, its inverse multiplied with the adjoint of A, which is again a 2 cross 2 matrix, right? So first of all, we determine what is determinant of A. So we determine what is the determinant of this matrix 2, 6, 3 and 5. So you can do that quite easily. So it would be equal to 2 into 5 minus 6 into 3, which is 10 minus 18, which is minus 8. However, we are doing this calculation taking the elements of the Z11. So that means we have to calculate it mod 11. So it is equal to 3. Right, this is equivalent to 3. Why? As minus 8, right, minus 8 plus 11 would give you 3, right? So this is the mod 11 calculation here. So this is equal to 3. However, we wanted to determine what is the inverse of A. Determinant A inverse would be the inverse of the element 3 and in Z11. We need to find it like this. So we know the identity here, the identity in this group Z11, that is 1, right? So therefore, what would be the inverse of 3? So we are looking for some x, x in this group Z11 such that 3 multiplication modulo 11 with x gives you 1, right? So what would be that number? Can you suggest that number? If I take x to be 4, in that case I would have 3 multiplication modulo with 11 multiplication modulo 11 with the number 4, it would be equal to 12. So we are calculating this mod under mod 11, so it is equal to 1. Hence our x is equal to 4 in this case, right? So here we have the determinant of A inverse is equal to 4, right? So we have determinant A as equal to 4. So let's mark our formula as equation 1. This as equation 2. Now what we are required to calculate? We have to calculate what is the adjoint of A. So let's do that. In order to calculate the adjoint, we first of all calculate the cofactor matrix. What is that matrix? In 2 cross 2 matrices, you can straight away calculate it, right? So the cofactor matrix is obtained how? When you just revert these two elements, write 2 in place of 5 and 5 in place of 2. So 5 would come here, 2 would come here, right? Yes. Then we have minus sign here, and you revert these two elements. So 6 and 3 would exchange places. So here we would have 3 and here we would have 6. However, we are doing this calculation under mod 11. So this thing would be equivalent to 5 would be as such, 2 would be as such. What about minus 3 and minus 6? So you can see that as minus 3 plus 11, it is equal to how much? It is equal to 8. So you can write it 8 here. And minus 6 plus 11, it is equal to 5. So you could write it 5 here, right? So this is your cofactor matrix. Now what is adjoint A? So the adjoint matrix of the matrix A is obtained when you have the transpose of this cofactor matrix, right? So it is equal to 5, 5, 8 and 2. So this is the adjoint matrix. Now let's mark this as equation 3 using equation 2, 3 in equation 1, right? So we are just substituting the values of determinant A inverse and cofactor matrix. We have A inverse, it is equal to 4 times this matrix, 5, 5, 8 and 2. Right, so you can multiply the terms together. It would be 5 into 4, 5 into 4, 8 into 4 and 2 into 4. So, and you can perform these calculations under mod 11. So it would be equal to 20, 20, right? How much is that? 32 and 8. And you can perform this calculation under mod 11 because these are not the elements which are present in Z11. So this is equivalent to how much? When you divide 20 by 3, you have 9 as the remainder. When you divide 20 by 11, you have 9 as the remainder. When you divide 32 by 11, you have 10 as the remainder, and 8 is as such because 8 is smaller than this 11, right? So this is A inverse. Now we can verify this thing. So we can verify whether this is an inverse. So let's calculate A into A inverse. What is the matrix A? It was 2, 6, 3 and 5. So it is 2, 6, 3 and 5. And what is the matrix A inverse that we have obtained? It is 9, 9, 10 and 8. So let's compute and calculate this. So it would be 2 into 9, that is how much? 18 plus 60, right? The next element would be 18 plus 48. The next element would be 27 plus 50. And the next element would be how much? 27 plus 40. So you can simplify these terms here so that you have 8 here, right, and 7 here. Here it is 66, right? 66, yes. Next element is 7 here and then 7 here. And the next element here is 7 here and 6 here. So we have to perform this calculation under mod 11. So this thing is equivalent to writing when you divide 78 by 11. So it goes on 7, right? And you are left with 1 as the remainder. So here we can write 1 here when we compute it under mod 11. 66 is completely divisible by 11. Right, so you have 0 as the remainder, so you can substitute 0 here. Again, 77 is completely divisible by 7, so we have 0 as the remainder in this case as well. And what about 67? 67 leaves 1 as the remainder. So what is this? This is the identity matrix. Hence we have verified that our A inverse, which we have computed here, this one is the correct one. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.